So our goal today is to finish these two boxes on your notes. And obviously, if you're using my flowchart printed from Canvas, we're going to take care of these two. Now, remember, we're trying to get the name of the compounds. Basically, we have two major groups. This group, unfortunately, has subgroups. It has two subgroups. This group is called binary, which contains two elements. And here's where it splits into two subgroups. One subgroup is composed of a metal, non-metal, and we have to take care of hydrogen. I'll take care of him today. And the other subgroup is, yeah, you guys, it's still composed of two elements, but they're both non-metals. The second major category is ternary, which we have three or more elements. We already did these two boxes last week, and now we're going to finish these two. Okay, so that's where I'm going to start. I'm going to start right here. All right, find your notes. I don't know which one you are using, but we're going to go right here. Okay. All right, where are we? We are ternary. We've got at least three different atoms in the formula. And you know now, ternary has two subgroups. We already did this subgroup to the left last week. So we're done with that. We're done with that. Okay, here we go. Here comes our last two sections. Same format, my friends. Same format. Let's take a look at the rules. So if I was to make that box, I'm going to kind of hold off on that box. I'm going to go here. I'm going to go over here. And just like last week, we have to take a look at the element or atom that's in front, which you should know by now is going to be your metal. And he has a positive oxidation number because he wants to lose electrons to become stable. You know from a number of topics ago and last week that we have these metals in front that have just one possible oxidation number, and then we have these that have multiple oxidation numbers. Okay, we did these single ones here. We're now in the very last part, which means we're back to these. We need to deal with these metals in front that have multiple possible oxidation states. So what do I have? I've got metals that have more than one oxidation number. We have to go back and deal with those when they make compounds composed of three or more elements. As you recall, the metal that has more than one possible number, you know what you have to do. You have to calculate the oxidation number, just like we did before in the previous topics, which was your topic number 9. We had to do this in 9. Well, you got to do it now in 10. You got to do that in 12. 13 and 14. Once you have calculated which oxidation charge that metal in front is going to use, you have to turn that thing into a Roman numeral. Yeah, I know, this is already hard enough, and then they throw in Roman numerals. It's like, I don't know my Roman numerals. I can give you the list of your Roman numerals to help you. Roman numerals state the oxidation number in the name. Is there one nice thing about the metal in front that has more than one possible oxidation number that you have to calculate and then turn into a Roman numeral? There is one thing nice. name stays the same. Thank goodness there's something easy about the metal that's in front. Okay, the back. You guys know that compounds are composed of two parts. We got the front metal and we got the back non-metal. Let's take care of that non-metal part. Non-metal, which you already know based on topic 9, that, oh my gosh, even goes back before even topic 9. Goes even back to your 6, that the second part's going to be negative. Where are you going to find these nonmetals tucked inside these ternary compounds? You're going to use your fifth best friend. They're right off of here. You need to use the polyatomic ion sheet. Just remember, poly means many, and atomic means obviously small, as in element size or atom size, and then ion simply means some type of charge, plus or minus. What do you do with the guys off of that polyatomic ion table or sheet? Well, the name stays the same. Stays the same. Thank goodness that part is easy. You don't have to modify these at all. You just simply copy and paste. And that concludes the rules for those ternaries. Okay, so if you're using the notebook paper and making your own flowchart, I'm sorry, it sucks. I know, I get it. We just did this box. So now let's go down here and let's take care of the bottom box, which you know from last week is simply where I place an example that I do first, and then I give you one to try on your own. Okay, so let's just scoot this whole thing down. Let's take a look at an example. Let me scoot this whole thing down. Good example. Let's look at this one. RH parenthesis C2H3O2. There you go. Oops, I want a 3. Let's go 3. All right, you guys can do this. Come on, you can do this. It just takes some time, some patience, and it takes a nice flow chart. That's how I learned how to do this, and I still use this flow chart today. And I think if I were you, I would just sit back and watch me do this. But listen to the order. Listen to the order that I use to attack this kind of problem, because you need to establish a routine or an order. If you don't, yeah, that's going to make it more difficult than it already is. So watch my routine or my order. So here's my flowchart, right? I don't even look at this thing. The very first thing I do is I see how many atoms I have. 1, 2, 3, 4. I have 4 different atoms in here. Then I flip this baby over. Well, if I have 4 different atoms, I know that I'm somewhere over here in the ternary part. I know I'm over here, which means I can only be here or here, which means I don't care about all this garbage. I'm either here or I am here. To find out where you are, you always have to check that metal in front. Does this metal in front, this RH, does RH have only one possible number, or does RH have more than one possible oxidation number? That's where you grab your fifth best friend, and you simply have to look him up. Hey, Mr. Rhodium RH, right in the middle of the table, how many possible oxidation numbers do you have? You've got 3. And that sucks. That spells trouble. That requires a lot of work from you to find out which one of these 3 rhodium is using when he's combined with 3 of these. So you get to go back to topic 9. You get to go back to topic 9 and simply do this. Man, I don't know what his charge is. I'll probably have to use his friend or his partner. Okay, C2H3O2, you know by now where those combos are located. They're located on the polyatomic ion sheet, and he's sitting right, hello camera, he's sitting right there, and that is his oxidation number. It's a -1. Oh, but wait a minute. Hey, I see some parentheses here with a number on the outside, and that tells me how many of these I have. Well, if each one's a -1, but I see parentheses and a number on the outside, now I know I have 3 of these -1s, which makes the entire right side -3. Well, according to topic 9, the left side has got to be the absolute opposite at +3. Because I want them to add to 0. But remember, you always end with some kind of a division problem because +3 is the entire side. They want it per individual rhodium atom. So what you've got to do is you better look right here. You better look right there in the corner and find out what number is there. What number is there in this example? There's a 1 there. They don't have to write it, but there's a 1 there. The math, easy. 3 divided by 1 is 3. But right now, right here, I'm going to turn that into a Roman numeral. 3, Roman numeral, is I, and I. At least it's easy. Okay, so let's go back and check. Yes, rhodium does. Yes, I've done this. Yes, I have this. What happens to the name of the metal in front? Thank goodness it stays the same. RH on your periodic table stands for rhodium. We have to use that Roman numeral to state the charge in the name. So I go back, I find that Roman numeral, and I bring it up here, and I put it after the metal, and I wrap it in parentheses. Done, 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 non-metal. Polyatomic ion sheet, find him, and his name will stay the same. C2H3O2 on your table, right there. That's the name. Simply copy and paste it. Acetate. Acetate. And that, my friends, is the name of that compound. A lot of work, huh? There is. It's a lot of work. And that work comes from the fact that that thing in front, more than one possible number. If this metal in front has one possible oxidation number, there's no math, there's no Roman numeral, you're done in seconds. Be careful with the ones in front that have multiple possible oxidation states. All right, now you know what we do. You've seen me, you've got the rules. It's time for you to practice, practice, and practice. Let me get rid of this. And a lot of this is from your topic 9. So if you have a good grasp of topic 9, yeah, this isn't that bad. If you're still trying to figure out topic 9, keep going. I would recommend you do it quickly. Let's see how you would handle this one. Hello, black pen. How about an osmium and this? And I'll save you some time. I'll show you where osmium is located on the table. It's quite an awesome element. Get it? Awesome and osmium. Okay, I'll stop. It's right there. So go ahead, do some damage on this one, and let's get the complete name for this compound. All right, go, 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 go. Okay, let's go. Let's see what you guys got. Here again, watch my routine. Nope, I don't even look at this. Don't. What you should do first, is look at the compound. 1, 2, 3. I have 3 atoms. Then I flip this baby over, and I already know I'm over here. Second thing, for the rest of your life, you better look up this guy in front to see if he has only one or more than one possible oxidation number. And oh yeah, osmium, that sucker is, look at the options here. This thing is crazy, absolutely crazy. That atom has 5 possible ways to lose electrons. Now obviously humans have been involved in some of these to make him behave the way he behaves, but that's still a lot, okay? All right, so I know that he's one of these. Okay, watch this. I'm going to calculate what it is. I'm going to turn it to a Roman numeral, but his name is going to stay the same. I'm going to do these 3 right now on osmium. How do I do that? Well, I don't know which one of those 5 he's using. Carbonate, CO3, I know he's on the polyatomic ion table. I know he has to be negative. And when I use this table to find him, and there he is, and I know his charge is a negative 2. Oh, here's where all important topic 9 comes in. You better be very careful. I don't see parentheses, which tells me there's only one of these CO3s. No, some of you probably put 3. For you to say there's 3 of them, you would have to see this. We don't have parentheses. We don't have a number on the outside. So I hate to tell you this, there's only one there's only one CO3 there. Well, that's negative 2, which means this side has got to be the opposite of plus 2. You better get your eyes right here and take a look. What number is there? Oh, there's only a 1. 2 divided by 1 is a lovely plus 2. And then right away I stay down here and I take care of the Roman numeral, which is, that's it. Guy in front, name stays the same. OS stands for osmium. Before I move on, I always search and find that Roman numeral. I place it behind. I know, believe it or not, some students will place it in front, and it's like, I don't know where you've been, but I've never placed it in front. It's always behind the metal. Done, 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 done. Okay, I'll look him up here, and when I find him, I'll simply copy his name. CO3 on the polyatomic ion table. His name is right there as carbon-8. I'll keep it the same. Osmium, carbon-8. There you go. That concludes your flowchart. So that takes care of these 2 that we missed last week. If you're doing this, obviously it's the same, 2 boxes. That should be done. And so now your flowchart should be complete. Hello, get out of there. Like mine. Everything is filled in. Canvas. Practice sheet. Yeah. Here's why you need a flowchart. You see why you need a flowchart? They're all mixed together. They're not going to tell you, oh, this is a binary composed of 2 nonmetals. They're not going to tell you that. You need to know where you are on the flowchart to figure out the name, because they're all mixed. They're not going to tell you, hey, look here, do this. Not at this level. They're going to mix them all up, and they have to. They can't. Okay, so here's what the practice sheet looks like in Canvas. Before we have too much fun with practice, I told you last week, hey, we got this including hydrogen, excluding hydrogen. What the heck does that mean? I'm going to take care of that right now to show you what I mean by including and excluding hydrogen. Right from your Canvas sheet, practice sheet, boom, look at the very first one. There's a hydrogen in there. I'm going to do this one for you, and I'm going to do this one because there's an H in front of that one. And then I need to show you this really weird combo that's actually quite common for us with this weird thing in front. Okay, I'm now going to show you those three. So I'm going to get rid of all this. The H is not hard. He's just weird because he can behave as a metal nonmetal, and so students go, heck, I don't know what to do with this guy. All right, your first one was H, F, and your second one was SO4 was an H3PO4. Let's just deal with those two first. And then all they want from you is the name. And so they'll give you a line. And I'm off the screen. There we go. Again, watch my routine. I'm not smart, you guys. I'm not. I just have a really good routine when it comes to taking apart science concepts. I just slow down. My very first step. 1, 2. I'm here. Now when I'm here, I've got a problem. Because I've got this combo of two nonmetals or this combo of a metal and a nonmetal. Here's where hydrogen causes some problems. If you take a look at the nonmetal, no. So we exclude hydrogen from this list. Hey, he's in front. Exclude him. So that means you are not here, which means you're over here somewhere, which means you're right here. So now we include hydrogen as a metal with one of these. I know it's kind of weird, but that's the behavior of hydrogen. So I'm going to include hydrogen over here, and I'm going to check it out on the table to see if he has only one possible oxidation number. And here's what students don't like about hydrogen. Look at hydrogen. You see why he causes a problem? But listen to this very carefully. He has only one possible positive oxidation number. One possible positive oxidation number. He's in the same boat as lithium. Only one possible positive number. Same as beryllium. One possible positive number. So that means, my friends, that hydrogen is one of these. And he does have only one possible oxidation number. He is one of these. What do you do with his name? Well, it simply stays the same. H stands for hydrogen. Finished, 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 finished. The nonmetal, find out who he is, cut it, splice it, change it to IDE. Who is that guy? He's this guy right here. I'm going to change fluorine to end in IDE. Fluorine becomes fluoride. And here's that special IDE ending. I think I missed an O. I missed an O. I got so excited changing pens. Fluoride is spelled really weird. It's U and then the O and then the R. I'm not going to mark you wrong if you misspell fluoride, but a lot of students flip the U and the O, which totally makes sense, by the way. I'm on your side. Done. That's it. Don't you ever use a Roman numeral for hydrogen. Never. Because hydrogen does not have multiple possible positive numbers. He doesn't. He just has only one possible positive number. So no Roman numeral for hydrogen ever. what do you do when H is in front of a bigger, larger compound? Again, watch what I do. 1, 2, 3. I'm over here. I'm here or here. How do I find out where I am? Oh, look what you and I put on our flow chart. He's here. He is not over here. So that means I'm dealing with these rules right here for this guy. What are the rules? Yes, you already know H has one possible oxidation number. We saw it earlier, so I'm going to simply keep his name the same. H stands for hydrogen. I've got this second part here to deal with. Where is that second part? Oh yeah. Okay, disregard the word gold, because that's how I would print off that table for you if we were in person, but in the CDL it's going to be white sheet. Hey, name stays the same. PO4 off of your third best friend table is sitting right here. There he is. Copy and paste. PO4 is phosphate, and you're done. So here's what I want you to walk away with when it comes to H's in front. Don't you ever use a Roman numeral. Don't. You don't have to. Second thing I need to show you, and these are very common, so be prepared to see these in later topics, 12, 13, 14. Look at this little nasty. But watch how easy it is to name something like this. Let me put him on the board. Okay, I'll put him down here. NH4. It looks nasty, but trust me, you're smart, you can handle this. You've got a great flow chart now. And again, watch how I do this. 1, 2, 3, 4. I'm over here. Second thing, if you've noticed, we always deal with the metal in front. Well, do you have a metal in front? No, you've got some weird combination of non-metals. So wait a minute, maybe I better look him up on this sheet. Now it is weird that he's in front, which means he must have a positive oxidation number. And sure enough, my friends, some of these actually do have a positive, there he is, oxidation number. But the key is, do you see multiple possible oxidation states? No, you only see one possible oxidation state. Boom. Only one. And look what you do to the name. It stays the same. And you also know that whenever you do use this table, the name always stays the same. Look, name stays the same, name stays the same. So don't change it. Don't change it now. We're finally doing something right. Okay, so here we go. This whole thing. His name off of that polyatomic ion table is ammonium. Ammonium. Just simply copied it. Well, I don't need a Roman numeral. There is no math to perform. Shoot, man, my grandma can do one of these. SO4, well, I know he's on here, and he's sitting right here, and I'm going to simply copy that name. And I am done. That's the only two spots you got to watch out for. H in front, and then if one of these guys shows up, there's the second spot. Okay, what are we going to do now? Oh man, we got to practice. We have got to practice, 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 and practice. The goal is for you to get the names of these compounds as fast as you can write your first, middle, and last name. So what I'm going to do now is I'm going to grab some of these off of your practice sheet. We'll probably do just 3 at a time. I'm going to give you plenty of time to get the answer to 3 of them, and then I'll show you how I got my answer. Then we're going to do 3 more, and then I'll show you how I got my answer for those 3. Here's where practice is extremely valuable, because they're all mixed together. All right, let's go. I'm going to pick 3 off of that practice sheet that's in Canvas. And I'm just going to go right down the line. Hey, I'm going to go right down the line. And here is the first one after the HF. You've got this one. Ni, C2, H3, O2 with the 2 on the outside. Okay, let's get the name of that one. And then the second one here is this one. And then the third one is this one. S2O3. Okay, as fast as you can write your first, middle, and last name, get the names of these 3 compounds right here. Get your flowchart, get your polyatomic ion sheet, and get your table. Okay, my friends, you're on the clock. You got 5 minutes. Okay, first thing I do, remember, man, it's all about the routine. Establish a good routine. You will probably be successful. But if you attack these different ways every time, I don't know what you're going to do, because you're creating more work for yourself. Just get a routine. So watch my routine. First thing I do, 1, 2, 3, 4. I'm over here. Second thing, always, for the rest of your life, you better look up the guy in front to see where you are. Does nickel have only one possible number, or does nickel have more than one? So you go to your table, you find good old nickel. He's right here, and that spells trouble. You have more than one. How much trouble does that spell for you? Crap, look what you've got to do. You now have to calculate it, you need to get it to a Roman numeral, and you need to keep the name of him the same. Let me do these 3 right now. Okay, so I am in a situation that looks like this. I have no idea what his charge is. I'll have to go to his partner. I know where to find him. I'll find him on this sheet. And there he is. And there's his charge. But I see parentheses in the formula, and I see this number on the outside. That tells me that I have 2 of them, which gives me -2. Well, if that side's -2, this side's got to be the opposite at +2. Get your eyes right here and see what number is there. Oh yeah, there's only a 1 there. +2 divided by 1 is 2. What does that mean in Roman numerals? Just an II. What happens to his name? Nothing. So, Ni stands for nickel. Grab that Roman numeral, wrap it in parentheses, and put it right after the metal. This guy, polyatomic ion table. What do you do with those guys? Well, the nice thing is you'll find him on that polyatomic sheet, but his name will simply stay the same. This guy on this sheet is right here. Ooh, hello camera. Hey, keep it the same. Acetate. Oh, I like that one. Acetate. Acetate. Done. I bet when you saw this one, you thought, oh, this will be an easy one. There's only 2 there. I don't see any numbers. Wrong. Wrong. This one is more work than this one. You can't tell by simply looking at the formula. But you could tell if you had a routine that this requires a lot of work just to get the name of this thing. Check this out. So again, here's what I would do. See my rules? Don't even look at them. Do this. 1, 2. You're here. Now, are you here or are you here? Do you have a metal, non-metal, or do you have two non-metals? Ah, crap. Now I need to find my table. I've got to find that zigzag line I learned in topic 5 and 6. There he is. He's here. He's on this side. And topic 6 would tell me, okay, he's a metal. Boom. Now you know that you're here. Here's the next thing you got to do. Are you here or are you here? You better look this guy up on your table and see if he has only one possible number or does he have more than one possible number. Well, here you go again. You got to find this stupid guy on the table. You have to search and look, and that, my friends, spells trouble because there's 2 of them there. That spells trouble. That will put you right here. Crap, he's got more than one. Now I got to do some stupid math. I got to turn it to a Roman numeral, but at least his name will stay the same. So what are you doing? You're doing this. I don't know what he is. Go to this guy. Well, you know he has to be negative. You better look him up on your table and find out what his only negative oxidation number is. Oh yeah, dude, that's a -2. That's his only negative number. Again, that came from topic number 9. How many sulfurs are here? Get your eyes right here. I don't see a number, which means, oh, that's a 1. If the right side is -2, this side has got to be the opposite at +2. And again, you better get your eyes right here and take a peek. What number is there? Oh yeah, that's just a 1. What's a +2? Divided by 1? Thank goodness the math is easy. Oh man, it's the same. Oh well. What happens to the name of this guy? Well, at least it stays the same. Cu copper. Better grab that Roman numeral right now and place it right behind him. And wrap it in parentheses. Phew! Where am I at now? Good heavens, this never ends. I'm now here. I have to find that non-metal. I have to cut and splice his name so it ends with I-D-E. S. Sulfur. I'm going to cut, I'm going to splice and change it to end with I-D-E. Sulfur becomes sulfide. There is more work on this one than this one. And this one looks nasty. This one's more difficult. Trust your flowchart. Use your flowchart. Ooh, I bet this caught a lot of you off guard as well. You got to be careful. They're all mixed together, my friends. So again, watch how I do this. My very first step. 1, 2. I'm here. Second, am I here or am I over here? Oh man, I gotta look up these two guys. Sulfur is here. Oxygen is here. Oh, look, I'm on the right side of the table. Topic 6 would tell me nonmetals. You are here. You have 2 nonmetals. Great, I get to use one of these. Here's the rules. Don't have hydrogen, thank goodness. Okay, use a prefix if there's 2 or more of the front element. Do you have 2 or more of the guy in front? Yes, you do. You do have 2 or more. So now the number 2 has a name of die. You have to use the die. So my very next step would be to do this. This 2 forces you to put the die in front. What happens to the name of that guy in front? Whew, thank goodness it stays the same. What is the name for the symbol S? Oh yeah, sulfur. You don't have to change it. Done with that. What's going on here? The back element. Ooh, students love to see that. They love to see the word always because it's consistent. It's easy. Always one of these. Always. How many do I have? You've got 3. 3, his name is Try. So now, this forces you to put Try in front. The second guy, you need to find out his name from the table, cut, splice, and add the IDE. O on your table is oxygen. You're going to change that to oxide. So I'm going to take this O. I'm just going to force you to change it to end with oxide. Woohoo! Gotta love those, man. Gotta love those. Okay, I hope you're seeing why you have to use this and the importance of this. And I hope you're finally realizing, yeah, you know something? I better count to see how many atoms I have to know where I am. And then after I count, I'll check a few things out. Metal, non-metal, or 2 nons if it's binary. If it's one of these, I'm going to get my eyes on that very first metal and see what's going on. Any questions? Okay, let's try these 3 now. Your goal, first of all, accuracy. Make sure you get them right. Your second goal, are you getting faster at knowing where you are? I hope you are getting better at using this. This is your lifeline, and you can use it. Okay, my friends, hey, keep working hard. I appreciate the effort. Let's try these 3 now. All right, you've got 5 minutes. You're on the clock. Go. Let's check. Again, watch my routine. 1, 2, 3. Hey, I'm over here. Second thing, if I am over here, I need to look this guy up in front to see if he has only 1 possible number, or does FE have more than 1 possible number. So you get out your 10th best friend and you check him out, and good old FE, oh, that spells trouble. Shoot, there's 3 of them. Okay, as soon as you see that, I hope you did this. Well, I don't know how many I don't know what his oxidation number is or how many of those I'm going to have. But I'll look him up on the polyatomic ion table. Cr2O7, there it is, and there's his charge, -2. So I know he's -2, but I see some parentheses with this number on the outside, and that's just screaming at you to multiply it by -3. Okay, so I get +6, I get -6 on the right, which means the other side has got to be the opposite at +6. Oh, that topic number 9. Ooh, hey, look what number's there now. Now we have a 2, so I'll bring that 2 down here. 6 divided by 2 is a 3. What am I going to do? I'm going to turn that to a Roman numeral right now. 1, 2, 3. Got it. Fe. There he is. His name is Iron. That's nice to know because his name will simply stay the same. Fe is Iron. Grab that Roman numeral and place it right after the metal and wrap it in parentheses. Good, done. Okay, man, where am I at now in this stupid thing? Yes. Poof! right here. So polyatomic ion sheet, once I find them, keep the name the same. Cr2O7 is a dichromate. Keep it the same. Dichromate. Perfect. Okay, my hand kind of erased the 3 that was here. All right, next one. Again, watch the routine, my friends. 1, 2, 3, 4. Holy smokes, you got 4 in there. You're over here. Second thing, again, you always have to look up the guy in front. Does osmium have only one possible number, or does he have more than one? Here you go again. Osmium. There he is. And that really spells trouble. That sucker has 5 possible numbers. What do you have to do? You play your topic 9 game. Well, I don't know what he is. I'm going to go to this nasty thing. Oof. I don't even know what that is, but I know where to find him. It might be on here. Where is that sucker? There he is. Look at his name. Hey, it doesn't matter. You just keep it the same. Okay, anyway, there is SCN, and there is his charge. So I know he's a -1, but I see parentheses with a number on the outside, so that tells me multiply, and I do. I get -3, which means this has got to be a +3. Get your eyes right here and look. What number is there? Oh, there's a 1. Oh my God, I did it again. Okay, so I get a +3, which turns into a Roman numeral 3. I don't know how I did that. I got 2 3s in a row. Oh well. Hey, at least I know his name stays the same. You never change the name of the guy in front. So, osmium. And I'll take that Roman numeral and I'll put it right here. I'll wrap it in parentheses. Things are looking good. Hey, this guy is off of that polyatomic ion sheet, and when it comes to those, it's easy. Just cut and paste. The name stays the same. Good luck trying to spell that fast 5 times. Thiocyanate. Thiocyanate. Done. Last one. This one looks easy, and guess what? It is extremely easy. Look how easy this one is, but I bet a lot of you missed this one. Here's what I'm going to do first. 1, 2. I'm here. Second thing. Ooh, do I have a metal, non-metal, or 2 non-metals? Which means you better look this guy up in front. He'll tell you everything you want to know. Aluminum. There he is. He's on this side of that zigzag line. That thing is a metal. Oh, perfect. I'm right here. Third thing, does aluminum have only one or more than one possible number? Looking back up. Oh, this is Easy Street. Look. Easy Street. He has only one possible number. Ah, finally, an easy one. Exactly. One number. There's no math. There's nothing to do. All you do is simply keep the name the same because he has only one number. Al, easy. His name is aluminum. What do you do with the guy in the back? Simply cut, splice, and add. Cut, splice, and add. Oxygen becomes oxide. No Roman numeral. And I bet a lot of you put a Roman numeral in there. You can't. He never receives a Roman numeral. That's a good place to stop, my friends. That's a good place to stop. Here's what I recommend that you do. Get into Canvas. Get a hold of this practice sheet. Try maybe 5, 6, 10 of these by the next time I see you on Thursday. Of the first column. Because then I'm going to pound out these with you. And then we're going to be heading towards part 2. of topic 10. All right, I am done. You guys have a great day. I will see you on Thursday. See ya.
Bye.
See ya.